So welcome first time that we get to see you, because the first time would have been you had watched the individual session one recording already that Ted and I did. And hopefully that it gave you a sort of a sense of how we were going to proceed and some information that we aren't necessarily going to go over. We're going to touch a little bit on some review of what you did in session one this session, but we're not going to do that again every session, just because we want to really focus on the organizing idea that we have at hand. So my name is Chris Arski. I'm one of the consultants with the CART Consortia, which is Central Alberta. But for the science, Ted and I have partnered up, and we are sort of looking after the first round of branching out throughout the province for all of you who are either piloting voluntarily or piloting because your entire jurisdiction is. And I'll let Ted introduce himself as well.
Thanks, Chris. Hi, everyone. I am Ted Zeroni. I'm currently coming from Sherwood Park, just east of Edmonton. So welcome, everyone. And thank you so much for taking time. I know it's a busy day, and we really appreciate you being here with us tonight.
Okay, so I'm going to start with our land acknowledgement, and then I'm just going to give you a bit of an intro on some of the things that we're going to talk about. Then I'm going to turn it over to Ted, and then I'll bring up the rear with some ideas of how you might unpack the actual teaching components of this based on what Ted is going to talk to you about. So in the spirit of reconciliation, we want to acknowledge that this gathering takes place on traditional lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. And so one of the pieces that I kind of started doing right from the beginning of session two is in our land acknowledgement, I'm going to try and talk a little bit about the land acknowledgement and how it actually links to your organizing idea. And because living systems is very referenced to the land or plants and animals that live off of that land, we have to always be aware that how we view things from our lens, our particular culture, our curriculum may not always be the way Indigenous peoples are going to agree and talk about it in the same way. One of the examples that I could offer you, and even more so, I guess, for next grade as well, when we talk about things like in grade 4, where they're talking about the rocks. A rock for us is an abiotic. It's a non-living entity. It has no life. But if I were to look at this through the lens of an Indigenous person, I would recognize that the rock does have life. It has a spirit, and it is very connected to the land, and it holds the history of a particular area in that land. So for example, the mountains, when we talk about the great mountains or the great skies, the great rocks to the sky, we're talking about rocks that have existed for thousands and thousands of years, who hold the history of everything that happened in that area. And so we always have to remember that there's two sides to it as well. So just as an example, we were having a conversation earlier this morning about traditionally in our grade 5 curriculum, we've always done wetlands. So wetlands has now been shifted to grade 6. But your grade 5 students are going to end up going over to grade 6. So when they actually meet with us in 2 days from now, I'm going to present to them the wetlands unit through the lens of the Indigenous peoples, as opposed to the traditional, here's the wetlands, what do we have, what plants do we find, what's abiotic, what's biotic. We're still going to talk about every one of those outcomes, and we're going to meet it, but we're going to meet it through the lens of the Indigenous culture. So we're going to use elders speaking to us about the importance of water, importance of cattails, importance of swamp water, like all of those pieces that we still meet the outcomes, but looking at it from a different perspective. Okay, so let's move on. We gave you sort of in an introduction in session 1 what our hopes and wishes were, and we're really hoping that by the end of this, you do have some confidence in that you have some materials that you can go forward with. Everything we're presenting to you as far as lessons or ideas are samples only. It's by no means the entire unit of what you would teach in grade 5, but it might spark some ideas of materials that you already have, things that you could already use that are existing rather than just starting from scratch, because a lot of the materials in here, you're not starting from scratch. You are able to go and borrow from another grade where it might have come from. or you might be able to build on a topic that you already had in your existing grade. So just to give you a little bit of direction and sort of that self-efficacy that I have the skill set and possibly some resources that can go along. And resources are some things that will give you some support with as well. So our norms, just going to touch on these this time around. Just basically, we're glad you're here. We know how busy you are. We appreciate it when you have your camera on. I think if you think about COVID times when you were back in the day when you had 30 kids on and you had 30 black boxes, how disheartening that was to talk to, and you didn't really know who you were talking to. So we do appreciate that. We also know that you can be multitasking and listening to us at the same time, and we're good with that. That's fine. And don't hesitate to chime in at any time. We're going to do lots of talking because we have such a short period of time to unpack an entire unit. But if you have anything you want to share, just unmute yourself and jump right in. Like, don't wait for us to ask for a pause or we might have missed something in the chat box. So moving ahead, our organizing idea that we're working on is living systems, and it did not involve kindergarten. It started in grade 1, and then it works its way all the way up through to grade 6, and then we're not sure what will happen after that. So we are looking at, oh, that is not the one I wanted. Okay, let me just grab a different, how come I don't have the right slide on there? Okay, Ted, I'm going to let you talk for a minute. I'm going to go grab the other one because I know there's a better one that has grade 6 in it. I'm not sure why I don't have it up there.
Well, we are in grade 5.
Oh, I'm sorry. My mind. I'm sorry, you guys. That tells me where my
You're
mind.
a day ahead.
I'm in grade 6. Duh.
Wow, good for you.
Okay. All right, we're good.
Thanks.
It's all yours. It's definitely all yours.
Very good. As Chris mentioned, the organizing idea living system extends from grade 1 up to grade 6 in this new curriculum. And the way the curriculum is organized is that at each grade, there's a little bit of a funneling down as to going deeper into a certain aspect of that understanding. So in terms of understanding the living world, at grade 5, we're looking at answering the question, how are organisms supported by biological processes and systems? And so the student learning outcome is directly associated with that question, of course. The students investigate the internal systems of organisms and explain how they support biological processes. So that's the big chunk of that that's being pulled out and examined in grade 5. Now, just a note on this, we won't be going through this every time, but as you go through your pilot curriculum, and I'm not too sure how many other units here or organizing ideas you're going to be piloting this year, but just know that once again, if you see the word include associated to one of the cusps, which is and I didn't talk about the cusps in the last slide, but I'll talk about those now. We're talking about the knowledge, understanding, and skills and processes piece. All those things together, those 3 columns, work together to generate information and for you to help determine whether or not students meet that learning outcome. So we're not reporting on the cusps, which is the knowledge, understanding, skills, processes. We're reporting on the actual learning outcome. So back to that other slide. So as you go through those cusps, you're going to find words like include, applied, and such as. And include means you do need to make sure to address everything, and students are responsible for everything that comes after the word include. If you see a word in parentheses, such as applied, and there aren't many examples I could find in grade 5. Certainly, there's only one example in the living systems unit. But there isn't, in terms of include, but there isn't a word in parentheses in this organizing idea. But if you see a word in parentheses, it means that students need to know that word, but can be used interchangeably with a grade appropriate term during classrooms and discussions. But when they're expressing what they know, we want them to use that word in parentheses. And finally, if you see the word such as, that does mean anything that follows, can be an example. It doesn't have to be used as an example, but it can be there if you wish to follow that. We touched a little bit, sorry, I was a slide ahead of myself this time. I just want to pause because we do get wrapped up in the curriculum and in the small and the minute details. And I just want to back up and stand back and just really take a moment to think about what is it that's really important for our kids to know. We need them to be knowledgeable for sure. And there are a lot of other things we want. When you think about those other things, they are really vital for our students to be successful in the future. And we know that future is unpredictable. It's fast changing. How do we hit it right so that when our kids leave our system, that they have what they need to succeed? It's tough, but there are some things I think we know that we can all agree on probably. If we were to throw out their words like, we want our kids to be model effective citizenship. We want our kids to be critical and creative thinkers. We want them to be innovative. We want them to be collaborative. All those things are really important. We know that it's those things that's going to carry them into the future. And so as we go through this, we're going to be looking at the lens with that in mind, that we can look at the curriculum and there's lots of knowledge in there, but that's not enough. What we have to do is move beyond our curriculum being just a checklist of knowledge, and use appropriate teaching approaches, teaching strategies to fill in the rest. And if we go to the next slide, we know that built in and intended to be part of the curriculum are the competencies there. And you can understand, you can imagine, you could take any one of those knowledge outcomes and just have kids memorize things and have them restate it. But we know we're not going to be hitting those competencies unless we choose some kind of approach that's going to have students learn and practice those skills. And that includes some of the literacy and numeracy pieces. And those progressions, once again, are identified in the Learn Alberta site, and I will make reference to them a little bit later on. So that's sort of where we're coming from, is that there's more than just a checklist, as I mentioned. We did talk about a conceptual lens last time, and I'm going to just pause again and say, let's look for a moment at this organizing idea through the conceptual lens of a concept. In other words, we're going to look at it, we're going to focus in on concepts. And once again, concepts are just one or two words. It's a thing that has distinct attributes or characteristics, and there are many examples of that particular concept. So we take a look at democracy. There's something distinctive about it, and it has shared attributes that we could say, yes, this system of government is a democracy, and this is not. So if we go to the next slide, what I'm going to ask you to do is pause for a moment and take a look at the very first understanding, that first row of information associated with the learning outcome for this particular organizing idea. What I'd like you to do is look at the learning outcome and the associated knowledge, understanding, and skill, or skills and procedures component, and see if you can pull out those things that you consider would be concepts and ideas that students would need to know. What are the concepts in this information you see here? And if you have a hard copy or something, or printed out of the curriculum, feel free to circle it or underline it. But I'll just give you a couple minutes, or not a couple minutes, just a few moments to take a look at it and see if you could find those things that are the concepts associated with this outcome. Chris, we could advance to the next slide. You might have come across these things, internal systems. Of course, internal systems is more specific than just systems, but internal systems, both organisms. Again, process would be a concept, but biological process is much more simpler. I've got complex organism, plants, animals. There we see systems again, organs, and so on. Generations, evolution, and they're repeated. And you can see that there's a big link, or a huge link, between the key concepts in the outcome and the cusps. So the intent is that the understanding is there by taking the knowledge and using it through a skill and process and working with it. Students get a deeper understanding of those particular concepts in this way that you see there. There are some other concepts that are important, and I guess coming back to it, so these are the things, these are the ideas that you want to make sure the students know and understand, because it's going to be pretty hard, as we'll see, to do a skill with it if they don't fully understand the concepts associated with it. There are some other concepts that you might have noticed, and they're more skill-related concepts, is what I'd like to call them. because they show up as verbs such as investigate or explain, but there's always an associated concept with that. So if we were to ask students to explain something, what do we want? We want something, we want an explanation. Some things are descriptions, some things are instructions, and some things are explanations. So what is an explanation? So there you can see that there are some concepts associated with those verbs as well. Just to keep that in mind as we move forward. So when you're looking through the curriculum, you want to pull these things out so you make sure students understand the concepts before you start doing things with them, such as connecting together or relating them or so on. Next slide, please. So the concepts in this, in all the units and in organizing ideas, excuse me, including this one, everything is organized just like the curriculum, from the broad organizing idea to the specific cusps. In this case, the concepts are organized in a similar way, such as going through living world process, more specifically biological processes, and more specifically respiration as a biological process. Keeping that in mind, what I did was, and you'll have a copy of this, is just took all the concepts that were identified in the organizing idea of living systems and organized them into a concept map. I do have a caveat at the top that there's only one possible organizational scheme. You may find that you may want to organize it differently, and it can be organized differently. There are a couple things that I have in dotted lines that aren't included, but I thought kind of would fit in, just sort of fill in the blank, because it doesn't make sense to just talk about change over time and just evolutionary without saying it's the opposite of revolutionary change, something that's a very quick change, which is over time. So you can see that this is also has a flow to it. You can read it. Living systems include organisms, which can be complex or simple. Complex organisms includes plants and animals who share biological processes in terms of through their internal systems. Plants or animals share have different systems that have different organs associated with them, and each organ performs a different function. And we can go on and explain it, but it gives you an idea of what the unit is like as a whole. Everything is, in a sense, related to each other, which is one of the key skills that we'll take a look at in a moment with the grade 5 system, or grade 5 unit here. So that conceptual lens does help us and to really hone in and focus in on things. Sometimes it's fun just throwing up pictures and informative, throwing up pictures and asking your students, okay, after we've covered a section, throw an image up there and say, well, let's take a look at this picture. What do you see? And then without giving maybe any focus, and then giving the focus of system. Is there a system that you see here? It could be the respiratory system. It could be the transportation system, perhaps. But what happened if you looked at the image through the lens of change? What ideas come up, or could you see? Or time? So the conceptual lens is there to help us not only to look at the curriculum, but it can be used as a thing to help the students do a quick check to see where they're at. Do they understand, and can they recognize exemplars of the different concepts that are taken in this organizing idea, or any of those for that matter. We're going to change gears and take a look now through the organizing idea, through the lens of skills and processes. And those are the doing words, the verbs, can be a thinking or an action. But there are a couple things to keep in mind. On the next slide, I have a list of highlighted all these skill words, the do words. So we've got relate, explain, make connections, research, identify, a couple times, create, examine, plan, and describe. And what I'd like to do is just slow down and read. Now that we've taken a look and see where they are, let's slow down and take a look at what they really mean. I've got a couple of tips to help you out with this part of the organizing idea, or this cusp, the skills and processes. So if you go to the next slide, Chris, I just want to make sure you point out that you clarify the skill. When you look at it, ask yourself, what does it really mean? And what does it mean to do that? I'll show you what I mean by the next slide. We take a look at relate. That's very straightforward. Relate means to make a relationship, or you could see a couple down, connections. So making connections and relating, the way I see it in this outcome, they're basically the same. You're making connections between things. Explain that groups of organisms can evolve over generations of time. It sounds straightforward. You might say just expect a verbal thing, but when we take a look and a stop and what do you mean, clarify the skill to you. What does it mean to explain or to create an explanation? It's something that's clear and understandable, and it can use graphics and sounds and images and so on. So once you get that fuller understanding of explain, you know that you might stop and pause and think about, well, before I get kids to explain that, the knowledge part and what they know, I want to make sure that they understand what an explanation is and what a good explanation is. And you could see that through the other skills as well. There are a couple of times throughout the guide, the word identify is used, and it's really hard to know what the intent of. I think in both these cases, it just means to state. And if you interpret it different, then you would teach it a little bit differently. But I find it hard that if kids were to ask to identify how oxygen and nutrients move through the body by investigating it on themselves and identifying that on themselves, they might have a tough time. So I think that's looking at, we work through it together, we research it together, and then have them identify those ways through whatever means possible. So those are the key skills. Step number one is not only do you clarify what the skill is, but clarify your intention with that cusp. You'll notice that with each of those skills and procedures, there's a doing part and a knowledge part. So you need to clarify your intent of when you assess this part, what you're really trying to assess. So you're trying to assess the part where they're relating, which is the skill, or you are trying to assess their understanding of organisms and systems and organs. So you want to separate them out. If you're going to just focus on, you want to know how kids are good at relating ideas and making connections, don't use this particular cusp to do that. Give them other opportunities to relate ideas together and show that they can demonstrate how to build, how things are connected to each other. And once they're good at that, then you can give them this and assess them both on their ability to show relationships and their knowledge about those things. One way that I do is to make sure that I don't rush through a skill and make sure they do get it. What I like to do is making sure that I could teach it first if I think they need it. If they can demonstrate to me that they don't need a skill, then we will just clarify it and talk about it to make sure everybody's on the same page. But if relating ideas is something new, you may want to use what I use, like calling as a skills teaching approach. It's direct. And it brings kids to the attention of what it is they exactly do when they're going to relate information. So I've narrowed down to 6 steps, and I'll refer to the surface, deep, and transfer at the end of the slide. But you can see this, the first 3 things are really what this is steps for the teacher, not for the student, all right? So first of all, you want to make sure you know what that skill is. And then we'll go on through the other steps as we go along, and I'll show them to you. So let's move to the next slide. What is the skill of relating? You Google it, you can find examples and so on. Everything I looked at, we kind of get the sense that to relate means to show or explain how 2 or more things are connected in some way. So that's the definition I might use for my students. The second step is identifying the steps. So if I was to relate 2 ideas together, what would I do? What would you do? You've got the word chair and you've got the word furniture. How are they related? So I broke it down to these 3 steps. And again, this is just an example of how it might be done. Want to make sure that to tell students, you got to know what furniture means and you got to know what chair means. You have to be able to be certain of those things. Once you know what those individuals are, now you can start making connections. And what kind of connection? What I did was go back to my language arts background and thought about transitional words and phrases in a paragraph, because really that's what transitional words and phrases do. They show relationships between what a person's writing. So if we could take a look at 2 things and have a cause and effect kind of a relationship. In other words, one of them will be a cause. So something could be, it causes something or influences something or affects something, or something could be an effect or result. And you could see there's all kind of different possible relationships that can happen. So when I use the example of chair and furniture, well, the relationship between them is that chair is an example of furniture, right? One thing is an example of the other one. And then I would represent my understanding or the relationship. So when I go through this with my kids, these are the 3 steps I'm going to teach them, or that they need to be aware of when I give them a question that asks them to relate ideas together. Next slide, please. After I know the steps, I look at it carefully and I make sure and identify the concepts that are in there, because I want to make sure if I'm going to give them a step, that I want them to know what the ideas are. Do they know what analyze and examine means? Do they know what cause is? Do they know what effect is, and so on? So I make sure I identify them, make sure they know it. And if I think they don't know it, I'm going to teach them what those concepts are before I even go through this list with them. So I'm going to assume, let's say my kids don't know what cause effect is. So I'm going to get a lesson ready in the background to make sure that they can understand the difference between cause and effect and understand those 2 concepts. So go to the next slide. Go ahead. We can use something. There's many ways to teach concepts. I like using concept attainment, where you give kids examples one at a time, and I already have a predetermined groups. And there are other ways to do this for sure, but this is the one way I might do this. And ask them these questions. What do the ideas in each group have in common? So if you keep going through the slides slowly, Chris, you'll see there's different things that show up in there, and categorized as group A or group B. And then you pause and say, well, what do all the group A things have in common that make them different than group B? Why do I have them grouped the way that I do? What does group A have in common? What does group B have in common? And then I might say, well, once they've given some time to look at it, click to the next slide. Where would you put these 2 statements? I drank some water and I was thirsty. Of course, we're looking at the idea of cause and effect. So my next question, go to the next slide, please, Chris. I think ask them to give some more examples. When I do this, I say, don't give me what the answer is, just give me examples. Give me examples. And then we talk about what is the attribute that they all have in common, and then we give it a name. And then we go on and tinker with that a little bit more to make sure they understand that. I think I have an example on the next slide. You might want to do that. No, we're into that step 4. All right, so I know the 3 steps is to make sure they understand the concepts, make sure they know how to use that chart and identify the things in that chart, and then they're going to represent the relationship in some way. You can keep going, Chris. So the 4th step then is to prepare modeling, prepare a model example. So if this was the first time I was going to introduce relating to the students, I would go through this and say, okay, what's the relationship between these things? And I think actually, if you go to the next slide, that slide should have been taken out. Yeah, that's where I wanted to be. What is the relationship between these ideas of sports, exercise, fun, relationship, hockey, football, and volleyball? How are we going to do that? Well, do we know what sports is? Step 1, do we know what that is? Do we know what that is? Okay, good. Well, what's the connection between those ideas? Then we go to that chart. Is there anything that causes something else? Is there anything that's an example of something else? Is there anything that affects something else? Is there anything that influences something else? And as we go through it, then they'll start seeing those connections or ideas. Next slide, please. So they might find this, that exercise, fun, and friendships are effects or benefits or whatever the relationship word is between sports. Volleyball, football, and hockey are all examples of sports. That's the relationship there. In this particular case, it's represented in a graphic organizer, a concept map. Or if you're teaching humanities and you want to combine it together, you can go to the next slide and say, let's do something in written form and start developing a paragraph out of that organizing idea. And you can see how you can expand some examples of sports like hockey, football, and volleyball, and the positive effects. You can expand that into a more well-developed paragraph, or just accept that if you want to know that the kid's in another relationship and you want to have the representation in written form. And there are other ways that it can be done graphically and so on. And so if you go to the next slide, then you go into deepening the skills, lots of practice, don't do mass practice, don't do this for a week and then stop for a month. intermittent, so on. This is the things that deepen the skill. To have them talk about what they're doing. It's that metacognition piece. Okay, so tell me, how are you going to show the relationship? Tell me how you're going to show the relationship between these two ideas or these three ideas, and have them talk it out for you. Have them reflect on the skill. What's easy about this? What's hard? How can we make this a little bit better? What do we need? And finally, one other thing you can do is explore to really deepen the skill of making relating is explore it on the conceptual level. So give them a bunch of just ideas and say, how would you organize these? What's the relationship between these ideas? That's, of course, deepening the skill, but they have to know what those ideas are, and they have to know what relating is in order to do this. Or here's them. And finally, what you want to get them to do after they fully understand is to transfer it. Why not have them make relationships between other subjects that you're teaching, so they can transfer that skill of relating ideas? Because at the end of the day, relating ideas is where the understandings take place. If you take a look at the understandings cusp, it really is explaining the relationship between, and talking about the relationship between two or more of those concepts that we take a look at. So you can ask them the question, what is the relation between behaviors, success, and support? Or any of the three key concepts that you identified. Now you're getting into transfer, a deeper understanding of the concepts. And finally, those again is just the 6 key steps in the skills teaching. Now you'll notice that I had them, keep going, Chris. Yeah, you'll notice that I had them in the process, in the categories of surface, deep, and transfer. And that's because we know that the learning process does involve that. We want to make sure kids have that really solid understanding of the individual skills, so that they're good at relating, they're good at comparing and contrasting, and their understanding of those individual concepts by themselves. They can distinguish between, what a system is and what is not a system. They can distinguish between democracy and not democracy. They can distinguish between living and non-living, right? That's that individual surface piece. Now we get into the deep piece where you start making connections. What's the connection between plants and animals, between democracy and voting, and so on? And then you get them to transfer that understanding into new and novel situations. And you'll see that skills teaching process has different things you'll want to do at each of those points to help transfer that skill. And as I mentioned at the front end, when we're moving into a future that we're not too sure what our kids are going to need to know and do, I think we can feel fairly confident that if we use the correct instructional approach, we can make sure our kids become collaborative, because we're going to put them in that position. We're going to use an approach that forces them to think about it and do that. We're going to create lessons and use instructional approaches that deepen their understandings or allows for that transfer that understanding. There's a whole list of different instructional approaches there. I know you're probably familiar with many of them or all of them, but it's really important, I think, to be intentional about why you're using an approach and where it fits into the learning process. You can help guide your students from that surface learning to the deep, to that transfer, which is what we really want. Even the skills, sometimes we forget that even those social emotional skills, we want our kids to transfer those things, but we start from that surface learning. What is empathy, right? We learn that in the classroom. How do they get a deep understanding? But where we need to provide opportunities to transfer that understanding. It's not enough just to know it. They have to lots of practice relating it to their experience and transferring it. And I think if we go to the next slide, that's what I mean when I talk about intentionality. We really, there's a lot of good resources out there, and Chris is just going to share with you a multitude of just marvelous things. And we take those as professionals and say, here's where it's at in this learning process to help me move my kids forward. And I'll pass it off to you, Chris.
All right. Are there any questions? I think what Ted has given you is exactly kind of the approach that I take when I start doing a unit. I look at, first of all, what those intentional skills and concepts are that I need to cover, and how am I best going to approach that? And I can honestly say, for my own personal style, I might look at all of the skills and process concepts that are being asked of the students And I may not necessarily just use them in the place that they were identified. I might use that globally to get things going. But again, it's important that they understand. And I think the example that Ted gave you with the sports is the way that you need to really internalize how we teach kids. We often assume that, man, they get into Division 2 and 3 and 4 and they know all this stuff, that I don't necessarily need to teach them all the nitty-gritty, and they don't. 18-year-olds don't know this. We have to be intentional about really making sure that they're solid in it, so that when we do get the product back that we are asking them to give us, it isn't just a surface level, few questions answered, point form, not sentences, nothing's deep. Everything is just a straightforward answer. And we wonder why. And it's because sometimes they don't know any different. This is what they assume it means to research something, just to tell you what they found, not to make any conclusions about it. Do you want to talk about this one, Ted, as well? Oh, you're muted, Ted. Sorry.
I never learn. As individuals and professionals, we have our ways that we like to plan. Some people like hard copies and cutting the curriculum up and moving things in pieces like that. Others like using, if you go to the Alberta Ed site, there's boards. There's this one, if you want to use, what it does is puts everything onto one page. It's a one-page planner for life systems, and there'll be one for the other ones where you can choose your organizing ideas that you want to focus on. You can choose the different knowledge, understandings, and so on related to life systems. It's the guiding question. And then the learning outcome is going to be, it's not on there, it will be, it'll just be the living systems learning outcome. But there's an opportunity there then for you to focus on what knowledge, understanding, and skills and processes you might want to work on through the drop-down menu. Those are the competencies that Chris has that are related to grades 4, 5, and 6. That you can choose that. Well, here's what I'm going to do. I might focus on whatever outcome, and whatever custom I'm learning on. Remember, there's always some certain concepts that are associated with them. You want to make sure to pull those concepts out, so that you make sure that you understand them, the kids understand them, that they're clear, right? Before you go on and start using them and have kids work with them. And again, the skill, what is the skill that you're going to focus on? Do they know it? If they're not, you may want to take some time out to actually teach what it means to do that. What does it mean to identify in terms of sometimes it's used as a verb to relate. Identify the connections, it might say, when it really means to relate, right? What does it mean to research? What are the steps in research? What are the definitions? So make sure kids have practice and research before you let them out and research something that they're responsible to know, right? There's that two-part, there's the doing word and the knowing word. We want to make sure they know that they're competent in the doing before we combine the two and assess them together on that. And then there's some other ways you can draw it in for planning. I was going to have when you get yours, access to one, what I'll have it, no, I won't. I'll have an example pre-filled, yeah, of one that would show how I would have filled it in using the relating activity that I did with you. There, I'm done.
Oh, that's good. So this will be posted in the folder that you'll have access to, and you can just download it and use it for each lesson that you create. I mean, it might be a 2 or 3 day lesson, but it gives you an opportunity to kind of just put everything into one place as well. And originally I actually had even the resources that I used, I had hyperlinked them to the bottom of the document. So that might be another place just to store them, so you're not having to go back into a drive or whatever. It's just there. If it's of help to you, that's great. That's what we're looking for. So when we look at the living systems in grade 5, this again, and Ted said the word, it's not a checklist. This whole science curriculum is not a checklist, but in some respects, it's written in such a way that it could very easily turn into a checklist, right? Where I just go down the knowledge side and say, got it, did it. Okay, I'm on this side. Yeah, we did this. We must have already completed that understanding because I did the left and the right side. And they were meant to be done in tandem. They're meant to be done together. And so being intentional about knowing what those concepts are, whether it's a skill concept or a knowledge concept, how are you going to marry those two together so that we actually are getting beyond just regurgitation of fact? We need facts. You can't go deeper if you don't have facts, but we sure can't park there. That's not where we want to stop. So what I've done, and also just want to point out that the curriculum was not written in a way that was the intent for you to teach it in the order that it's presented. They are giving you a number of understandings and the knowledge and skills and processes with each of those understandings, but it is not intended that you have to go in the order that it's presented. In actual fact, in most cases, it's probably better if you don't do it in the order that it's presented. But again, that will depend on your style. It will depend on how you're going to unpack this with the students. What kind of an activity are you doing? How is the unit going to be organized? That will determine entirely on how you're going to order what they're going to see first. So in my particular example, I would probably start with just cells and just a general discussion about how cells might have changed over time. And I'm going to unpack this more so with you. I'm just going to give you a brief overview. I would then move into not only looking at systems, and notice I put biological systems together. I'm looking at what are the systems that they're asking us to address. And we're going to even touch a little bit about moving into a biological process, because it's pretty hard not to talk about the system and get into the biological process that goes along with it. They kind of get hand in hand. So in some respects, you could just sort of put this as one big component that works together. Again, it would depend on how you're going to unpack it with the students. And then we have all these different systems that transport things in our bodies. How does it work for a plant? So looking at it in a comparison to a plant. The deep learning that might come into this is what's common between the two. What do plants and animals share when it comes to systems? They both have to eat, right? So they may not have the same system inside of them, but what are some of the common things that they need to do? They certainly don't all have movement. They do have growth, right? So I'm going to take you to a slide deck. You will have this entire slide deck, so you don't have to worry about screenshots or anything like that. You'll get it all. You'll be good to go. So we just went through that. So when I looked at just the cells, and this is straight out of your document, this isn't anything that's really a lesson. It's more of a reminder of, we're just talking about how cells might have changed over time. It isn't going deep into Darwin. It isn't going deep into all of that historical pieces. And that's a little bit problematic in this particular organizing idea for grade 5, is in some cases, it's really hard to know just how deep you're really going to go or how surface you're going to go. So trying to find a balance in between there. There's a couple of issues. I'm going to point those out as I go along as well. But really, we're talking about, there are still in existence today organisms that are made of one cell, and they're happy to live as one cell, and they survive just fine. Or we have multi-celled organisms like ourselves, where we have a bunch of cells that work together to do a particular function. Whereas in a single-celled one, I have either a single cell, or I have all of the same kinds of cells, but they might have the same things inside of them, multi-cells inside, but they're all the same. There's no difference. There's no differentiation in them. So when I look at an organism, I'm talking about something that is made of cells, and organisms in particular generally have multiple systems inside of them. So the bear is an example. We're an example. This, not so much as an example. The jellyfish, not so much as an example either, although it is an organism that survives and it has different functions, and I actually am going to give you a bit of info on that as well. So again, we talk about students and we want to know what they know and what they don't know. And I'm big on that. When I teach, I don't care whether I teach grade 1 or whether I teach grade 12. I'm always big on knowing what did they know before I launch into something, because if they know a lot, then I'm not going to hang down at those entry-level questions. I'm bumping it way up right off the top. Because if I ask them something that's a little bit over their heads, then they're going to have to do a little bit of searching to get to an answer for that before we even get going. So first question might be, does anybody even know what a life process is? So I might throw that out. I might have that as a shoulder partner, have a conversation with somebody. What do you guys think it is? Talk it out. Again, asking these kinds of questions in class, when we talk about engagement strategies, the worst thing we can do is say, anybody know what life processes are? And look around for hands up. We need to say, I'm going to give you 1 minute of dedicated think time before anybody's allowed to speak. In other words, give everybody time to really think about what the question is that you're asking, and then they can talk to their shoulder partner or however you're going to set it up. But they need that intentional time. So you can have that conversation, throw some ideas up on the board and see what they come up with. They might get them all. Okay, they might have a really good idea already of what they are, but if they don't, we could talk about them. We could say, what keeps us alive? What are things that make us alive? Well, that we grow and we develop, we change over time. You definitely look definitely look different than the day you came home from the hospital. We take in food, we have nutrients. So does a plant. We reproduce, we give off waste. We react to surroundings, loud noises, cold temperatures, hot temperatures, hunger, bad weather changes how we have to react. Okay, those types of things. And we release energy. So these are typical examples of a life process. Could they be described using different words? Absolutely. And I would interchange them with whatever the kids come up with if it's so close to it. We want them to be able to think in terms of their own thinking. So we might want to start talking about, let's just think about what makes us us. Okay, how did we get started? So we think about single cells, and if you think about the outcome, the way it was worded, or the understanding, it's asking us to say that cells have evolved over time. If they were watching anything with the Mars, if they've been watching anything with the lunar landings over the years, so you got some kids who are really into space. You get some kids who are really into archaeology, paleontology, right? And they find these fossil diagrams and rocks. We can grab their attention by that and just talk about, they're noticing that they're finding single cells, big cells that existed like 2,500, 1 million years ago. So we still have single-celled animals that live. They are single cell. They don't have multiple things in their body. How could I show them that? Go and get some pond water. Let's take a trip out to the nearest pond that you can find in a slough. Go get a microscope, put a couple of drops underneath, and let them have a look and see what's shooting around in the water. Most of those are going to be single-celled. Okay, so we're looking at all the different types of opportunities. We also want to talk about things like algae. Okay, they hear about algae right now. There's blue-green algae in the lakes. Don't go swimming in the lakes because you're likely going to get sick. Your animals might get sick if they go in. Well, algae is a single-celled organism. We can go get that from the pond water and have a look at it, and we'll see those single cells. We'll see them looking like this. Bacteria is another one that they often don't think of. They know bacteria sometimes makes them sick, but they don't realize it's a single cell. And bacteria and viruses. Viruses sometimes can be single-celled as well, right? But they have very different shapes to them. So having a look at this, going and borrowing a microscope from the bio department and just getting a couple of different size slides with the cells on them for students to have a look at. Some singled ones also have little cells floating inside of them. So kids will get fooled and they'll say, oh no, it's more than just one circle. Yeah, everything that's inside is all the same. It's all doing exactly the same thing. It's exactly the same cell that you're seeing. So it's still a single cell. And sometimes they get confused by that. We can find that in pond water right now in Alberta. These are all things that we can go get and that they could see. It doesn't take us anything other than a microscope and a couple of drops of water. If you wanted to have a bit of a sense of a little bit about a jellyfish, because some of them, you might ask, how many of you have ever been to the ocean? How many have ever seen a jellyfish? And talk about what a jellyfish is. And you can watch this video that I've embedded in here. You could stop it at 7 minutes and 34 seconds. This counts down, there's 13 key facts about a jellyfish. Talks about doesn't have a head like a brain like we do. It talks about the fact it doesn't have legs and yet it moves, right? All of those things that multi-celled organisms are doing, this thing's doing, but it doesn't have all the things that we have. And then it talks about a particular one that actually has teeth on it. I'm sure not everybody needs to see, but I guess if you've got some gutsy kids in it, then by all means, go ahead and watch the whole thing. It's also important for them to understand when we talk about multiple cells, what does that really mean? So looking at how blood flows through the system in our bodies, this is an actual photography. So you take the light microscope and you watch blood running through an artery. It's important for them to see what that looks like. This is happening inside of them so that they start to get a sense of, we're going to be talking about systems pretty soon, and one of them is the cardiac circulatory system. So we want them to have a little bit of a sense of what that looks like, and they're fascinated by stuff like this. It's important for them to see what's available to them and how those cells have arranged over or grown over time. So when we talk about one cell or unicellular, I try and throw some other words in them, they're not necessarily in our curriculum, or multicellular, we have definitely got cells in our body that we don't actually use. And that's pretty fascinating for them. So before we even get to the system part, we might say, did you know that we actually have things in our body that are there, but don't serve any purpose anymore? They might ask you what it is. Well, one of them could be the example of an appendix. Okay, years ago in caveman days, men ate, or people ate a lot of, not just men, but people ate a lot of green plants because that's what was readily available. We needed to have a body that could digest the cellulose from the green plants. We definitely don't have that anymore because we have definitely refined our eating habits and we've changed it to become meat eaters and plant eaters, and in some cases, one extreme to the other. So the purpose of the appendix was for them to have something in their body that could help digest all that plant. But we don't do that anymore. So what happens is it's called a vestigial organ. It's an organ that sits there. It does have a purpose, a little bit of a purpose when you're born. It helps with your immunity system, but that wanes off by the time you're 7 or 8. It kind of loses whatever it was doing. And it just becomes either I'm here and you don't know about me, or I get inflamed and I get appendicitis and I have to have it removed. And that's about the only time you actually really know it's there. We have other organs in our body like that, but that's just an example. And it's important for students to know that over time, as we evolve, things changed in our bodies. So cells change over time. We don't need to get much deeper than that. When you get into talking about how do cells change in multicellular organisms, we start with cells that group together and they have a common job. And when they group together in a common job, they're called a tissue. And when those tissue cells group together to come up with a bigger job, in this case, they form an organ. And that organ is generally associated to an organ system in our bodies. We have organs in. So our organ system defines how that helps that particular organism survive. And you cannot have a single organ system survive on its own. There's no animal that can just have one of them where everything else falls apart and one survives. We can't live that way. So we need the whole thing all working together. So we have multiple organ systems, and that's what creates an organism. So up here, you'll have just a very short...
Cells like this one act together to form tissue. This then gets together with other similar tissues to form an organ. In this case, the liver. This is part of a system, in this case the digestive system, which works with other organ systems to ultimately form an organism. In this case, you, Paula.
Wow! So my body's made up of cells, tissues, and organs.
Right, which enable us to carry out the 7 life processes that prove we're alive. Cells like this one act together to form tissue.
If you want to take them one step further and show them what happens when those cells keep building and growing and dividing, they can actually watch over 6 minutes the development of a salamander so that they can see that it does come up into different parts and creates different parts of the body for this salamander to be created. Again, what we want here is for students to simply understand that I can have a single-celled organism and I've evolved over thousands of years and they have survived in the form that they're in now. And we have multicellular organisms. And that's about how deep we want to get, because our biggest hat we're going to carry here is on the systems. That's what we're looking at.
Cells like this.
So again, we look at how do we develop an organ? Multiple cells come together, form a tissue, multiple tissues that are the same job get together and form an organ. And then that becomes part of a system that works together amongst other systems. Now, our goal really here, if you think of all the words that Ted showed you, our goal is really for them not just to regurgitate for us what each of those systems are that we're going to study, but how are they connected? So keeping connection in your mind is the big rock here. How are they going to be able to make those connections? And it may be, remember, as I said, without facts, I can't go deeper. So I may have to do the factual piece first. Let's understand what the systems are all about. But then I need to be able to make comparisons. I'm able to say that these systems have things that they have to do in common. And that's the important part, the digging deeper down that we want to do in this particular grade, in this particular organizing idea. So this is sort of their basic piece that we want them to understand. And that's what they're going to use in each of the systems. What cells were there, what tissues are, what organelles are in there. Now, they don't go very deep into these systems. They have very specific organs that they've identified. Could we go beyond that? I think in some cases you might have to for it to make sense. But you don't have to go crazy where they're not doing Bio 30 and they're not going to be writing a diploma. So we don't have to get crazy on that either. But we do want them to be able to make comparisons. They should be able to see how simple organisms and complex organisms do have things in common, right? So this is that comparison, that deeper. Where's the connection between these two? I should be able to take a Venn diagram like this and maybe put digestive system and circulatory system at the top and say, what would be in between? What's going to be on the outside for each one? What's in between? Where do they work together? Where is it that they support each other? That's your goal for grade 5. So you might choose a research, you might not. Here are the systems. And if it was me, the first thing I'd be asking before I'd even shown this, I would just say, let's make a list, call out whatever systems you know. Just make a list and see what they know. Find out if they know any systems at all. And they probably do quite a few, but there's going to be lots on here that they don't necessarily know, or maybe they don't know the names of them. They can describe them to you, and that's okay. Put them down in their own language. But what do they know? What systems are available to them in their minds? What have they heard before? For me, I would actually use a 4-corner activity. And if you've never seen a 4-corner activity, basically you have sort of 4 signs you put up in the room. You could, depending on how big your class is, you could just put them across the front of the room too and have them line up. It's just easier when they're corners because then they can huddle together and talk. So agree, disagree, somewhat agree, don't know. Okay, and you can change those words depending on what you're doing. I'm just throwing out an idea for you here. Again, you can change this to whatever you want. But some sample questions might be, I'm just going to throw out a question about a system or a statement. And I want you to go to whatever corner you feel you agree, disagree with the statement, you somewhat agree with what I said because you think there's actually more to it, and that's the critical one, or I have no idea. Okay, and they don't just get to go to the corner and stand there. They actually are going to have to account for why they're there. So it's not like you can just choose don't know every time. That's not going to work either. So the circulatory system is about the heart. So a lot of kids are going to go to agree. You might have some students that are going to come down here and say, I somewhat agree, because it's more than just the heart, right? There's blood involved in it. There's all kinds of things involved in it. So again, it's teasing out what do they know and what they don't know. And when they're down here, whatever corner they're in after you give them their statement, I'm just giving you random statements here. You just ask them, okay, I want you to talk to the people that are in your corner. Why did you guys pick that corner? And the one thing that they can do is, oh, you know what? Is that what you guys were thinking? I'm in the wrong group. I'm over here. I disagree, or I agree. So even talking to their friends, they may find that they start teasing out some deeper thinking. Blood plays a role in the circulatory and the respiratory system. Do you agree with that statement or not? So they may go or they may not go. They may just say, I disagree because the respiratory system has nothing to do with the blood, right? So then that tells me right off the bat, they don't know any connections there. They don't know the purpose behind it. and so on. You could change this to whatever you want. You could even just talk about the musculoskeletal system. Like if you just want to put one and just ask questions about that. You could say, this is the name of a bone, just see if they know. The femur is the name of a bone. I agree, I disagree, I'm not sure, right? I might get rid of the somewhat. So that little video that's there, if you've never seen a Four Corners work before, that just shows you an example of how they do it. So I won't go through that one right now. But here's really the crux of the 4 systems that we're looking at, right? They're not asking us to look at all of the systems, which is a little odd. And I'll say that right off the top. I find it a little bit odd because it's hard to say that these are the 4 that are running your body, because there's some other things that are happening in here too, but we're not studying those, and they don't come up in grade 6 either. So I'm not sure if those are later for grade 7 or what's happening there. The other piece that's in your document is reproduction as one of the biological processes. And I'm assuming, I put it in red, I'm assuming that's an error on their part, because it does not fit into any of these systems. And so I'm going to park that one for now. I actually have that question submitted to Alberta Ed to get some clarification. Did they intend to put the reproductive system in, or was that just shouldn't have been there, right? So I'm parking it for red for now. I'm ignoring it. If we need to bring it up, we can always talk about it later. So we talk about the 4 different systems. And in this case, I am approaching these through the lens of research, identify, and design. One place they're asked to actually draw a body and put those organs into the body. So there's your model. Can they create a model after they've done some study? Could they create a model and teach each other about each one of these? So this is the part about when Ted was talking about being clear on what it is that you want them to do as far as the lens that they're going to do as a product. I'm going to use research, and I'm actually going to even tie that into the math data analysis and grab some outcomes from there as well. And I'm going to just have students pick. They can go in groups of 2s or 3s, and I would suggest we're going to talk about each one of these. Now, we're going to talk about what research means before we get to that, before we can get, so they're very clear on the depth that we're looking for, that this is not just a 1-statement, 2-paragraph report. That's not what we're looking for. They're going to teach the rest of the students, and how they model that instruction is entirely up to them to choose with input from me. So you have the circulatory system, and I won't go through all of these, but what I did is I went through and I grabbed what would be age appropriate for grades 4 to 8 materials. So you've got the circulatory system, you've got resources in here that you can use. They are not by far the only things that you could use, but they would work very well for what they're doing. If you're going to unpack one system as a group together so that you teach them what you're looking for using one of them, I tend to use videos, and I use a different one every day. So today we might have started with this one. They learned all about it. Tomorrow I'll just show them another one which reiterates what we've already learned, but it's a different video. So there's always a little bit of something different. And then the third day I would do something else. So they're always kind of like reading a book. You read a different book with the same topic every day with students. Same idea when we're doing this kind of unpacking of concepts. With the respiratory system, I would do the same thing. This would be one where I would ask them to do a model, or maybe that would be an experiment that we would do together. How do we model breathing? And I can do that with a plastic jug and 3 balloons. That's all I need, and 2 straws. So I can create a model lung. And how do I know that I was successful? Well, if I pull down my diaphragm, once I learned about the lungs, if I pull down on my diaphragm, my balloons will pop up and they will work. So it's a very easy one. If you live in a farming community, I know it might gross some of you out, but I would go and get lungs from a cow and I would bring them in. And if you get some really strong-winded kids, you just hold your hand around that trachea, put a big straw down the center and blow, and you'd be amazed at how big they puff up. And it just fascinates the kids to see that these things actually blow up and how big they get. So again, it's up to you what you feel comfortable with.
What's up, dudes, and what's up?
Resources here again that you can use, different aspects of it, or the students could use those, right, if they're doing the research. There's a couple of places in here. One of them I'll just ask you to note down, Kids Health. Kids Health is a free site. Anybody can log into that. I would suggest as teachers that you go there. So if you click this one on later when you see it, just sign in and get a free login. There's lots of info for lots of your organizing ideas in science, not just for this one on there. So it's a really useful little site. The digestive system, same thing. We're talking about what are all the pieces. This is an active link up here. And then the liver and pancreas will will be drawn into the conversation as we see how food moves down. So again, we want them to be able to unpack all of the pieces, not just here's the organ, here's what it does. We actually want them to be able to put those together. And then the musculoskeletal system, we're taking not only the framework that holds our body up for support, but we're talking about the muscles at the same time. Usually they're pulled apart, and kids will say that. I've never seen a skeleton with a muscle like that. It's usually because we talk about them separately, because usually if you're doing science, you're doing anatomy and physiology. Physiology is a muscle, the anatomy of the bones. So that doesn't mean we can't do them together, but we certainly, it complicates it a little bit. Again, they're not having to learn 206 bones of the body and 630 muscles. They are needing to know some of the major bones, just some of the big ones, like your femur. And why do I want the femur? Because that's where my red blood cells get made, right? So that ties in with my circulatory system and keeps me healthy. So there are some big bones that we would want to know for sure. Again, I put some links in here, facts, kids and teachers. Again, this is how body works. So there's a teacher site and a kid site. And then all of these are interactive for you. So depending on which system you're doing first, if you're not doing living systems right now, then it gives you a chance to go through and just have a look at which one of those would fit your style and what you want the children to see. So then the last part would be and I'm not sure why it says the respiratory system. Sorry, that's not correct. That is talking about my plants. It should be interconnections with plants. So when I talk about the interconnections with plants, I'm talking about what system does a plant have in it? How does a plant eat? And they did a little of this in grade 4, but not a lot, not to any depth. So now we're talking about how does water get drawn up? How does food get drawn up? And food goes in 2 directions in a plant, in the phloem, whereas the xylem, the water, only goes in 1 direction. That's what helps keep the plant rigid as well. So we want to look at those pieces, and I've got those linked for you in here as well. We want to typically, I know lots of people have stumps that they could bring in to see the rings on the stump. So this is a good time for us to talk about that. We can talk about the age of it, because that tells us how many years of water we're seeing come up those different areas. This is another site here I just put a note beside it for you. So these slides are not always set up for students. They're more set up for you to decide what you want and to grab off of the slides, or to grab the slide and just take them apart. The New Zealand site is a great site for science in general. So again, it's a free sign up. So when you go in there, have a look at that and just grab some of those pieces. So this is one where students may not do a system in the body. Maybe they're plant kids. Maybe they really like to go talk about plants and they want to see how those fit. So you would have that contrasting presentation of each of the different systems and how they worked. In this case, I could do the old-fashioned colored food dye and celery, right? Watch it come up so you can see where the colored draw the tubes are for the water to come up.
Look at all the.
It's a great model for the students to be able to do. I've included some slides here from another slide deck, which I've included the full slide deck for you in your folder. But again, if you're needing a little bit of talk, if they're not remembering a lot from grade 4, because they may have missed a few pieces, remember, talking a little bit about the purpose of sun. You're not talking about photosynthesis and how it happens. That's grade 6. But we can talk about the fact that they need sun and that they need that to make food. Unlike us, we could stand out in the sun all day and all we would get is a sunburn, right? So basically we can talk about photosynthesis, but we're not going to get into the nitty-gritty of it. Not now. That will be for next year. Talk about the different roots, and remember that the roots draw up the water, they draw up nutrients. Nutrients can go up and down. Water can only go up. right? It can't go in the opposite direction. And then again, if they just need a bit of a reminder of how an animal develops, or sorry, a plant develops different than an animal would, we could obviously do that, or we can just look at it again and talk about it. This would have been covered in grade 4, in the new grade 4 curriculum. They would have talked about this. And then again, just labeling. So there are lots of sites that will allow you just to pull off a sheet like this if you want a quick formative assessment to see if they can just do basic labeling, or after there's been some teaching, we could talk about that. So there's lots of sites that you have that I've already said, go to this and sign up for it. They have these types of things for you, if you don't already have them. I mean, a lot of you will have these from your previous courses. So let's talk a little bit about what might this look like for assessment, or what might this look like for transfer. So I might look at this triple circle and ask them to compare circulatory system and respiratory system. I could take all of this out. It's editable, so you have a copy of this. You can just go in here and take these out because they've already covered the identification of the organs, the function of the system. They've located it in the body. They can put it in the body. Okay, we've done our teaching piece. We're all on that page. I could ask students individually to come up with what are the distinguishing features of the circulatory system and the respiratory system. What do they have in common? Are there jobs that they share? So such as the transportation of oxygen to the cells, right? I need the blood to do that. The blood goes to the lungs they pick up the oxygen, take it out to the body, pick up the garbage, CO2, bring it back, right? So those two work in tandem to one another. Or what about the digestive system? Does it have any role with the respiratory system? And if not, then this would be blank. If it does, then there would be something there. What about circulatory and digestive? They definitely work together. So again, this could be an assessment for you to see what deeper learning they have, or it could be your transfer opportunity, right? For them to have some further dialogue where they'd have access to their resources. Again, it depends entirely on how you're doing this. There's a couple of other links in here for you. Scienceforinquiry.com is a great site. Again, it has only science in it, and there's lots of resources there for you as a teacher. And lots of those fill in the blank kinds of things too, if you're looking for something like that. This is another one that we've been putting into all of the grades so far. We used it a lot in grade 1, 2, and 3. But I actually wasn't going to put it into 4, but the 3, 4 teachers were saying they really liked it. So again, depending on how you set your unit, maybe you want to use this one as a sum up my thinking. Maybe this is your quick assessment, or maybe this is your transfer where you put a question up here and now they're going to fill in how these are connected and what they are, right? How are the circulatory system and digestive system related? What functions do they serve in common? What are the similarities? What are the differences? So again, I could fill something like this in. It depends on your style. These are just there for you to use if that's what you want. This one, to me, is kind of, I guess I'm looking at this as a nurse. I used to be a nurse, so it's kind of hard for me to see 4 systems and not the rest of the body working together, because it just doesn't work that way. So I did pull this off. If you have some high flyers who are just really into this, and some of your kids will be, maybe they want to go and try another one. Maybe they want to find a different system that they don't have to study and compare it to one that they've just learned about. Give them that opportunity to do so. So again, it could be a transfer. I wouldn't give this to every student, but it would be an opportunity for them to show what they know. In addition, in your folder, you will find a copy of an assessment rubric. So originally, when we were getting new curriculum, we were supposed to roll out with British Columbia at the same time. Their science is somewhat similar to ours, but they had created rubrics for science and technology, and those rubrics are really easy for scoring. So if you want something that's consistent that you could share with the students so that they could always look to see how am I doing, but you would use the same one, or you could edit it if you want and adjust it according to what you've just asked them to do. So I put that in there if you are looking for a scoring rubric that you can use for both either oral conversation or as a review, sort of where you're at. Are there any questions on that slide deck? If you are wanting to do something with coding, there is an opportunity. I'll throw the link into the chat box. You can grab it there. There is a company, they're an Alberta company, and they're opening it to grades 1 to 9. If you want to log in with them, they will teach the students and you, your class, they will do the teaching on how to code with a little robot. So if you want to do it with somebody, that's fine. If you want to wait until October 26th and we do some of that activity, then whatever you feel comfortable with, or both. I mean, it's whatever you feel most comfortable with. But this is just an opportunity. We're not saying it's the end all be all. I just came across it. I haven't logged in myself because I don't have a class. But if it's something that interests you, they will take you through it. There's no cost to it, anything like that. So it's really a matter of what works for you under the circumstances. Okay, are there any questions at all? Anything that we didn't answer, anything that you're wondering about, anything about the website?
Chris, there's one chat question about sessions covering computer science and scientific method. We don't have a designated session for those. The intent is that they're going to be integrated inside the activities that we do, or inside the sessions that we have with the other ones. But there is that, as Chris mentioned, that particular some sessions on coding, for example. So we don't have a session currently planned for those particular organizing ideas.
If you read the computer science and the scientific method, they should actually be integrated into every organizing idea that we do. Like, it should be just pulled into it. And I can bring in the computer science with gizmos. What Ted and I are going to be doing shortly is just trying to go through the gizmos to see where's the complete link, like where does it really match for grade 5, what matches for grade 4, etc. So we're trying to get a better handle on what they have available, because some of them sound good, but they're not a good match. So we just want to make sure that we're recommending. And once we do that, in your folder, the same place that I showed you session 2, any subsequent ones, if we find a gizmo or 2 or 3 or 4 that fit to that organizing idea, we'll list them in there so that you would know to go and get that one. Doesn't cost you anything for gizmos again. So it's just a matter of knowing which one is a good fit for grade 5 living systems, which one is a good fit for matter in grade 5, and so on. So we'll try and discern those through and put those lists up there, and then you can get them from the New Learn Alberta site, or as Gizmos will tell you, you can go directly to their website because it doesn't cost you anything, and just upload it from there. Once you're there, you've got everything right in front of you, so you don't have to go back and forth to the New Learn Alberta site. So whatever works for you under the circumstances. Okay, so that's our intent with those as we keep going through. Are there any other questions? Okay, well, we will get these off to our tech department, and he's been pretty good about trying to get them up the same night that we send it to him. But nonetheless, just be sort of watchful for your grade 5 folder there, and it will have all of those materials in it that you're looking for. And if you have any questions at all, don't wait for the next session. Just fire us off an email or phone us. You've got our numbers there. So just give us a call and we'll be glad to step you through, or sit down and brainstorm if you're planning and you just want another person to sound off with. We'll do that with you. We just need to know what can best support you. And if you do have anything you want to share, just send it my way and we'll create a shared folder where people can just go in and grab things that you've shared out. And if you're willing to share, are you willing to share it with anybody that's doing pilot science, or do you want it just to keep it in grade 5? So that would be an important piece for me to know. Much, everyone. I hope this is a little bit helpful to you to get started, and we will journey together in November and maybe in October as well.